above the track. Then the contact wire is strung beneath and held by droppers. From the contact wire, the electric locomotives will draw power. This overhead equipment is designed for running speeds of up to 100 miles an hour.
Wish they could do something about these tunnels.
So do our chaps. Wiring on open track is a complex operation, but in tunnels, the small headroom is just a big headache. The limited space and the harsh lighting bring a nightmare quality to the scene. Most of the work is carried out at night when there's less traffic. The work is arduous, and weekend working is the rule rather than the exception. Permanent fixtures are made later from a free-moving trolley or from the roof of the wiring train. The position of the contact wire at each structure is staggered so that wear on the pantograph is spread evenly. The height and deflection of the contact wire is checked. Now, this is a glass fiber section insulator used to separate two electrical circuits. A smooth passage for the pantograph is essential here. Later, high-speed test runs are carried out using a specially instrumented observation coach.
Must be near Rugby. There's that big concrete silo on the M1.
Yes, a familiar sight on the motorways.
The completed assemblies for a section of the line are marked for their locations and are loaded in sequence onto the cantilever train. From the store racks, they are passed up through a hatch to the roof of the specially adapted coaches where the insulators are fitted. These are often greased and wrapped to protect them from smoke and atmospheric pollution. This protective wrapping can be removed quickly, leaving clean insulators ready for commissioning.
Another item of special plant which we adapted is this articulated platform to aid the rapid erection of the cantilevers and other items. When all the supports in a section are completed, wiring can commence. One of the most important aspects of production is the manufacture of the copper wire conductors. From bars cast in the group's own refinery, thousands of miles of solid grooved contact and stranded catenary wire are produced in our mill. The wiring train is a well-equipped unit. Inside is stored a comprehensive range of tools. Whilst not engaged in wiring, the engineer prepares schedules for future installation, working from drawings supplied by the site office.
The stranded catenary wire is run out first. At each support, it is lifted into a temporary pulley. At the end of each run, it is pulled up to the correct tension for the temperature existing at the time. The end of the wire is then connected to the termination assembly. The temporary pulleys are now replaced with the permanent suspension clamps. Inside the train, men prepare the copper droppers from which the contact wire hangs. The length of each of these is calculated to fine limits. They are made to the correct length and stored in sequence until required. Working either from ladders or the top of the train, the prepared droppers are clipped to the catenary at measured distances in each span. The contact wire is now run out. Each drum of wire has been ordered for a particular length of track and has been supplied from the factory to the right length. Subsequently, the droppers are fixed permanently by means of a patented clip, which fits into the grooves of the contact wire. To ensure good current collection throughout the temperature range and at high speeds, the equipment needs to be automatically tensioned. The middle of each run of conductor is held by a midpoint anchor. The catenary is insulated on each side of the structure, but electrical continuity is maintained by a jumper. There is up to half a mile of equipment on each side. As the temperature rises, the conductors expand and move away from the midpoint anchor, so the equipment must be able to move in the along track direction. The cantilevers are therefore hinged to the mast to allow this to happen. A constant tension in the catenary gives a constant sag in each span and results in an evenly graded or level contact wire, which is necessary for good current collection. At the end of each run, the equipment goes to a pulley arrangement with a 3-to-1 reduction. The correct tension in the wires is maintained by these weights, which can move freely, descending as the wires expand with higher temperature and rising as the temperature drops.
Lonely miles of route, worked and guarded for long generations by transport men who match the elements with their lives.